Good to have you today for another interesting section of our study series. It's been a worthwhile experience since we started this section in March, April first week, and we're running it straight down to first week of June, which is about next tomorrow. We're starting the next month next tomorrow. And today it happened that we'll be having our guy at the top, the most experienced and senior cloud security consultant in the person of uh, David Okeyode. And David Okeyode is a cloud security consultant, and he has helped a lot of companies around the globe to secure their public cloud environment and containerize workloads as well. He's the current EMEA CTO Azure Cloud at Palo Alto Network, and he has been doing a lot, and he has been a great pillar behind the success of this user group as far as we are concerned. So, Mr. David, welcome to the section. How are you
I,
doing today?
as you were describing the person, I thought you were describing yourself, also, Imoh.
No,
I
it's
thought you
you,
were
sir.
describing yourself. So, so it's a
Yeah,
pleasure to be here. It's a pleasure to be here.
yeah.
Yeah.
Thank you so much, sir, for offering to anchor this section. The floor is open to you now.
No, no problem. So first of all, like apologies for the event because I was meant to do a session last week. So apologies
Yeah.
that I was not able to make that because I miscalculated at the time. I was at the Build conference in Seattle, and that was the reason why. So the timing didn't work out well because I was meant to be proctoring the session, and then everything didn't work out. So apologies for that.
Yeah,
Yeah, but we're
no
here.
problem.
We're here today, so we can get started.
Yes,
Okay.
okay, sir. Yeah, I will
So
go back to the next page now.
yeah, no problems. So let's do this then. Let's go to the screen and I'll share my screen. So yeah, hello. So let's see. There we go. That's better. So hello everyone and welcome to this session on microservices on AWS. So before we get started, so I can see we have a few people that have joined live. So if you can put information about who you are and where you're joining from, put that in the chat window. I'd like to know who exactly we have on the line now. And also, there is a little short quiz that I'll throw in the middle of this session. And there is a prize that we're going to be giving away um, to whoever gets the question correctly. I'm not sure if Imoh is still there, so I'm not sure what the prize is. What's the prize that we can give away for today?
Yeah, yes, sir. Hello, the prize is if you are winning a section, if you are winning and if you answer question correctly, you are entitled to win a $25 AWS worth of credit. And this credit,
Nice.
will help you to practice on AWS. Having that
Okay.
real life experience is better for you. So that's the price.
Awesome. Thanks for clarifying, sir. Thanks very much. So there you go. So right as I go through like the session, I'll throw in a quiz question, and whatever comes out on top in terms of that quiz question will get $25 worth of AWS credits that you can load into your AWS account for practice. And actually, I do have certain homework that I'm going to give out today also. So that's, the credits are going to come in handy. So we have Kennedy from Abuja. So Kennedy Uche, thanks very much for joining. So who else? So put in the chat window your name and where you're joining from. So just put that in the chat window. So it's good to know who is currently online. So we have Kennedy. Thanks for joining. Kennedy from Abuja. So as you put forward your name, I'll highlight that. So let's see. So we have Ubaidia from Adamawa. Hello, thanks for joining. Ubaidia, apologies for messing up your name. Sorry about that. Ubaidia from Adamawa State. Welcome. Welcome. Nice to have you online. Okay, so I think that I'll get started here because there's a few things to cover before we get to the end of the session. So today we're going to be talking about microservices on AWS. What we're going to be doing is we're going to be looking at exactly what microservices are, what are some of the principles and benefits behind that, why do organizations use them, what's the benefits that they get from using them, And we're going to be looking at some of the approaches, some of the considerations that we need to look at if we're planning to implement microservices on AWS. So we're not going to be delving into services and architecture and implementation today. We're going to be taking a step back to look at the big picture around microservices. So let's get started by defining what microservices are. What exactly are microservices? Well, here is a nice definition from AWS. Microservices, it says here, it says it's an architectural and organization approach to software development. Let's stop right there. I love this definition. What this definition tells me is that there is an architectural approach when we talk about microservices, and there is also an organization approach. One of the downsides that organizations have whenever they try to do microservices, it's either they're just focused on the architectural side and they miss the organization side. So I'll give you a good example of that. Whenever we talk about microservices, AWS comes up as an example. You know, the Amazon company themselves. Amazon transitioned from being from monolithic applications to microservices at the very beginning. You know, the Amazon.com website, right? Transitioned from being a monolithic application to microservices because it was becoming very hard for them to implement the changes that they wanted to implement, and they realized they had to change their architecture. But it wasn't just the architecture that changed, they also changed their organization approach. Some of you may have heard of the term two pizza teams. Two pizza teams at AWS. And that is what that is saying is they divided their organization, the development organization, into very small teams. And the whole idea behind that is if a team is larger, if a team, you should be able to feed a team with two pizzas. If you need more than two pizzas to feed the people in the team is too large, right? So they broke them down into smaller teams, and then they tasked the team to go deliver different services, right? So there's an architectural side, there's an organization side. And it says, continuing with the definition, it says, in which software is composed of small, language agnostic, and independent services. What it's saying is that microservices is a software architectural approach. It's a software architectural pattern where instead of having a single unit of software with multiple processes running together, what we have is we have individual, independent, small services that makes up our software. And those small services, they can be language agnostic. We can write one of them in Python, write another one in Go, write another one in .NET, does not matter. And then it went on to say they communicate over well-defined APIs. That's the whole idea behind microservices. Just keep that in mind. There's an architectural side to it. There is an organization side to it. I mentioned earlier in terms of the organization side, I mentioned like the two pizza teams. So services are owned by small autonomous team, and you can see the pizza right here. So you have much more smaller teams that are doing the work. So anyways, let's go on. Let's see a sample use case. So the representation that you're seeing in front of you right now, this is a sample e-commerce site or e-commerce application. So a traditional e-commerce application is made up of multiple processes that are tightly connected together as a single unit. So here you have a process that handles the business logic for the cart. You have a process that handles the user authentication. And then you have another process of business logic that handles the search for the website, for the e-commerce website. But they are all tightly coupled together. They're developed together. They are stored in a single code base. They're deployed together. And they're using, of course, a single database. What's the problem with this architectural pattern? Here is the problem. As the application code base grows, then it becomes harder to make changes to the code base, right? Why? Why does it become harder? Because if you want to change just the code base relating to the cart process or the cart business logic, it can have an impact on the entire software because everything is tightly coupled together. So a single tiny change can end up impacting everything because everything is a single unit. Everything is deployed and developed together as a single unit. They're all tightly coupled together. So, hard to make changes. Hard to make changes. But is there any other downside apart from being hard to make changes? It's also hard to experiment. And if you don't experiment, you cannot innovate. So because it's hard for me to make changes, I'm much more reluctant to try things out. Say, oh, what about if we switch this? Do we get any improvements? Because I'm concerned that if I switch that, it may affect the whole thing. So I'm more or less likely to experiment. So less experimentation. And also less innovation. So that's some of the downside to monolithic architectural patterns. But then you have the equivalent of the same e-commerce website, but now in a microservice architectural pattern with the components decoupled from each other. So now in this component, in this architecture that you can see here, software is now divided into independent components. So you have the user service that's running as an independent service by itself. It has its own databases that it's using to persist data. You have the cart service that's running independently. You have the search service that's running independently, and they're all using their own database. And this has advantages to it, right? Number one advantage is you can select the technology that is best for each service. So maybe in the case of user authentication, it's best to maybe leverage something like a relational database service. Then you leverage a relational database service for that. If you're doing something like an e-commerce cart, right? Maybe that's best with a much more distributed database service in terms of leveraging things like maybe DynamoDB, unstructured, or this is not unstructured, it's some like semi-structured database services. You can leverage DynamoDB. In terms of the search service, you can leverage a service like Elasticsearch. So you can select the technology that best fits your services. So awesome. I can see we have a few more people that I've mentioned. So we have Onyedikachuku from Lagos. Hello, Onyedikachuku. Thanks very much for joining us. And we have Elizabeth from Lagos. Hello, Elizabeth from Lagos, Elizabeth Ogumola. And we have Obashiro Olakunle. So thanks very much, Kunle from Lagos. Thanks for joining us. Awesome. So I hope that you're getting some information here. So we'll carry on with what we're talking about. So let's go a step further. So what are some of the characteristics that we should look for when we're talking about microservices architecture? So we saw an example architecture here with the components decoupled from each other, right? We can develop them independently. We can deploy them independently. We can update them independently. Right? And one of the things that I forgot to mention is one of the advantages of a microservice architecture. This one, it adds to make changes. This one, it reduces the risk of making changes. It reduces the risk for us. So if I need to make a slight change to this service, it does not have a direct impact on the other services. So I'm much more likely to experiment and I'm much more likely to innovate, right? And then we can deploy this much more quicker because we're not deploying everything together. I can deploy this much more quicker. I can release 10 versions of this in a day if I want to, because again, it does not have a direct impact on everything else. So it's about reducing the risk of making changes. So some of the characteristics of microservice architectures. And also, if you have questions as we go on, just put your questions in the chat window. I'll be happy to address your questions. Here's some of the characteristics of microservice architecture. Number one, decentralized. What does that mean? What that means is in order for us to call something a microservice architecture, it has to be, the software has to be made up of multiple services that are decoupled from each other. So there must not be like processes that are tightly coupled together. You have different services decentralized, each service handling a function of the whole application. Polyglot is another characteristic of microservices architecture. What does polyglot mean? Polyglot actually means speaking multiple languages. That's what polyglot means. But in the case of microservices architecture, what that means is we can use different programming languages, different technology stacks for the different services. So the user service can be written in Python, the CAD service can be written in .NET. Does not matter, they communicate with each other over APIs anyway. Independent. What does that mean? Changes in one service in the microservice architecture should not have a direct impact on the functionality of another service. So that's what it means by independent. Because I make a change in the user service, it should not have a direct impact on the functionality of the CAD service or the search service. Another characteristic of microservice architecture is focus. The focus. Microservice should, each service should do only one thing, right? Because the goal is not to begin to pack them all together where you pack a lot of business logic together and they're functioning that together and they're trying to accomplish that together. So do one thing well. So the user service does only one thing, authenticates user to the service. The search service does only one thing, for searching the database for the items. The card service does only one thing, stores the items that users have selected in the cart. So all these services does only one thing. So they do one thing well. So each service should be that way. It says here it uses the term black box, but what that means is that the other services that are part of the application, they should not need to know how they each work internally. The user service does not need to know exactly how you've implemented the search service. Because if it needs to use the search service, it can make a call to the search service over API and provide the necessary data. It does not need the full details of this is how you've implemented this service or this is how you've implemented this service. In other words, they're all abstracted from each other. This one is a very interesting thing. This was a code, excuse me. That was a code from like one of the AWS technical leaders that said that code in terms of how they structure their teams. And it says the way that they structure their team, the team that builds the application runs the application. So if you build it, you run it. You don't necessarily have to follow the same approach, but it's just saying lessons that we can learn from how AWS has implemented microservices in their own organization. So the team that built it run it. That's why you hear about roles like, site reliability engineers or, SREs. So you probably have maybe team members, SREs, that have a strong knowledge in software development, and they have software dev, and they have strong knowledge in operations, and they are members of the development team, of the feature teams, of the service teams. So these team members can provide expertise to the rest of the team on how can we run the software that you're building. But the whole advantage behind it is that the team that are responsible for building that single service, right, they have much more deeper understanding of that service, and therefore they can quickly respond to issues that arise, and they can they can take a higher level of ownership and accountability because they understand the service. So that's the whole idea behind that. So in order for us to be able to call something a microservice architecture, you must see a combination of these characteristics in that architecture: decentralized, polyglot, independent. Services are performing only single functions. They are abstracted from each other, and typically the teams that build it also runs it. Okay, let's see. Any questions in the chat window? Let's see. So we have a few more people that have identified themselves. So we have Adeyemi Lawal from Lagos. Thanks for joining. We have Dennis Musembi from Kenya. Thanks for joining, Dennis. And we have Jamilu from Abuja, Jamilu Muhammad Usman. Thanks for joining, Jamilu. We have Bumi from Badagry. Thanks for joining, Bumi. And so that's it for now. So again, remember that there'll be a quiz question, just one quiz question. And whoever gets the highest score is going to get $25 worth of voucher. So just make sure you stay tuned because that will come in the middle as I'm going through the session. Okay, anyways, let's go through the rest of the session. Let's go back to the slides. So what are some of the benefits of microservices? So we've seen like some of the components, we've defined microservices, we've seen some of the characteristics that we should look for. What are some of the benefits? Number one benefit is scalability. I can scale each service in a microservice architecture independently of the others. So that's one of the benefits. Another benefit is about rapid build, rapid test, rapid release cycles. New releases takes minutes. We can add features very quickly. So what does that mean by rapid release cycle? Because when we're talking about microservices, you have a smaller code base. So for the different services. So what that means, we can build them quicker. If I'm only building the user service, I can build that quicker. I can test it quicker because there's less things to test, right? I'm only testing for a few functionalities and maybe a few integration capabilities, and that's it. So if I have a smaller code base, I can build it quicker, test it quicker, release it quicker. And that allows for more rapid releases. Again, I can release 20 versions of that a day versus if I'm releasing 20 versions of a whole e-commerce website. That is much more difficult to do, right? So short time to add features. In the case of having a microservices architecture, in some cases, adding a new feature is as simple as introducing a new service. Maybe you want to add some new service to your e-commerce website. Instead of having to redesign everything, you just create a new service as part of your microservices architecture and you integrate it with the other service. So you have shorter time to add new features. We have clear ownership and accountability. So I mentioned earlier that the teams takes ownership of the service that they're building. Easier to maintain and evolve the system. Again, you have smaller code base, so there's much less things to do. Increased agility, so we can build new features without having to start from scratch, just add a new service. Faster innovation, because again, less code base to deal with. Technological freedom. What microservices architecture does is that sometimes it forces people to use technologies that may not be the best one for the work that they need to do. So everything goes into a relational database because that's what the application uses. But not everything should go into a relational database, right? So that's some of, this gives more technological freedom. If that service benefits more from using different technology than what other services are using, then you can implement that technology, right? They don't have to be the same. Here's an example microservice reference architecture in AWS. So this is a sample, 3-tier architecture. So you have a user interface or the user layer. We have the business logic layer, and then we have the data layer, the persistence layer. So we have this 3-layer reference architecture. In this particular case, the user layer or the front end tier that's running on Amazon S3. So Amazon S3 supports a static website capability. So that front end is running on Amazon S3, where you can load your static code into that. And then it's using Amazon CloudFront for global caching. And then the business logic layer, so that's been containerized, so that's running on Amazon Elastic Container Service, Amazon ECS, and it's accessed over the application load balancer over the ALB. And then for the persistence layer, for the data store layer, we're using multiple services depending on the type of data. If it's structured data, well, we can store that relational database. If it's unstructured data, we have things like DynamoDB. We have Elastic Cache for cache data. So it's using multiple services, again, depending on the use case. And one of the things that you find in AWS is that there are multiple ways to run microservices on AWS. So typically, if you want to run microservices on AWS, you can run them either as containers, or you can run microservices as functions. So here is my first quiz question for you today. And you have to use the chat window, and you have to be very quick. So pay attention to the quiz question. We said you can run microservices in AWS as containers or as functions. Now, there are 17 ways to run containers on AWS. The first person to list, or the person that lists the highest number of ways to run containers on AWS will go home today with the $25 voucher. So I'll carry on, but get in the chat window, and there are 17 ways to run containers on AWS. Whatever method that you know to run containers on AWS, yeah. So Ojo, what will probably be better is that you want to put all of them together, so I can easily collate them. So EC2, ECS, EKS, so put all of them together, all the ones that you want to list, put them all together, and then send them. So don't send them individually. It becomes more tougher. So just use a comma to separate them. So list them, use a comma to separate them. So awesome. So I can see. So, and then we'll get to that. So, and whoever gets the highest number gets that. So I can see lots of like stuff here. So whoever gets the highest number gets the $25 quiz for today. 17 ways. Can you imagine that? 17 ways to run containers. Actually, there may be more than 17 ways now, but let me see. Very interesting answers here. Okay. I'll give it a few more seconds, and then we'll have to count. So give it a few more seconds, and then we'll have to count and see. So I can see. So let's give it a few more minutes. Let's see. Okay, I'll do a countdown, and then I'll need to select a winner so that you're not Googling. So we have to get started. We have to get going now. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There you go. So that's it. So 6:28 is the cutoff. Okay, let me bring this up on the screen very quickly. So that's too late. Sorry, Jamilu Mohammed. That's too late. So that's the cutoff points already passed. So here is a blog post that was written by Corey Quinn. Some of you may know Corey is popular in the AWS community. Sorry, Kennedy, it's too late. Adeyemi Lawal, sorry, that's late. So we already had a cutoff already. So the cutoff was 8:28. So sorry, 6:28, and that was the last person that I had was Toyib Mohammed Jamil. Okay, anyways, 17 ways to run containers on AWS. So you have Proton, App Runner, Lightsail containers, Lightsail, and number 5, EC2, EKS, ECS, Rosa, AWS IoT Green Gas, Code Build, EKS Anywhere, and ECS Anywhere, Fargate, App2 Container, Copilot, Elastic Beanstalk, AWS Lambda, and there you go. 17 ways to run containers on AWS. So I'll put that in chat window. So let's see who the winner is for this one. So let's see. So the last person was Toyib. So let's see. So that's 1, 2, 3, 4, 5, 6, 7, 8. So then is 1, 2, 3, 4, 5, 6. And you and they 1, 2, 3, 4, 5, 6, 7, 8. So that's a tie between you and they and Toyib already. Isaac at 1, 2, 3, 4, 5, 6, 7, 8, 9. Isaac at 9. Oh, I was. Let's see. let's see. So 9. So Kennedy. So Isaac is currently leading now. So Kennedy has 1, 2, 3, 4, 5, 6, 7. Ichem has 1, 2, 3, 4, 5, 6, 7, 8. So we have 3 people tied at 8. And Ojo Williams Daniel has 1, 2, 3, 4, 5, 6. And okay, so I think we have a winner for today, ladies and gentlemen. And our winner is Isaac Adekwiton. Isaac has 9. So he has 9. So Isaac, congratulations to you. So in the chat window, apologies. So in the chat window, you should see an email address, awscloudsecwestafrica@gmail.com. So just if you send, I think it's at outlook.com. I think it's, is it not at Outlook? I thought it was at Outlook.com. Okay. So either at Outlook.com or at gmail.com, send to both of them. And if you send your email address, and then we'll get the voucher over to you. So that's for Isaac Adekwiton. Thanks very much, everyone, for participating in that. Okay. So let's move on very quickly. So you can run those as containers or as functions. And let's see. So congrats, Isaac. Well done. Okay. So let's get back to this. So APIs are typically front end of microservices because, again, we said we can run our microservices as containers or we can run them as functions. And how do they communicate with each other? How do they communicate with other services? They communicate using APIs. So here's another reference architecture. So in this case, you have microservices that may be running on EKS, EC2, ECS, Lambda. Again, depending on how you've implemented that, maybe as containers or as functions. And because of the level of complication, because the more you scale, the more difficult it is to manage the amount of APIs that you have making up an application. So that is where services like the Amazon API Gateway comes in. So Amazon API Gateway can help to abstract a lot of the complexity that has to do with like API management. So for example, maybe implementing capabilities like traffic management, filtering requests, routing requests, caching requests, authentication, authorization. Instead of decentralizing all of those with all your microservices, you can centralize those capabilities to the Amazon API Gateway. And that can help you to essentially minimize the management that you have to do. So Amazon API Gateway is an important service when we're talking about microservices, because that's how we expose the APIs. That's the preferred way to expose the APIs for the services. So are microservices appropriate for you? Should you be implementing microservices for your applications or not? So this one is it's very, very interesting because there was a recent article that came out where the Amazon Prime team came out with this article right here, which I'll put in the chat window. So they came out with this article right here in March of this year. And the whole point of this article is they said they moved from a microservices architecture to a monolithic architecture, and they were able to reduce their cost by 90%. That's very interesting. Because many people will say, oh, if you want to build modern applications use a microservice architecture. But here is the Amazon Prime Video team saying that actually they achieved a significant reduction in cost and complexity by moving away from a microservice architecture to a monolithic architecture. One of the key things, take away for me for this, is microservices architecture is not the only way to build modern applications. You can build modern applications without using microservices architecture, using a monolithic architecture. But what that also means is that we should carefully consider our use case to see if we're going to benefit from a microservice architecture before adopting it. What are some of the things that we should consider in a before adopting a microservice architecture? Number one, consider your architecture. If your code base is a small code base, if you have a single team and they can deploy frequently, you may not need a microservice architecture in order to be able to implement that. Again, read the story of the Amazon Prime team and read how they've been able to get better value by implementing a monolithic architecture. The other thing to consider is your data management, right? If you have large relational database in a monolith, that may hinder your ability to build independent components. So then you have to determine, what do you prioritize the most? Do you prioritize performance over consistency? Can you accept eventual consistency? So look at your data management layer and look at the sorts of data that you're storing and look at what you're willing to accept in terms of consistency or in terms of performance. Computing is another aspect to consider. Does your application have a predictable load? If the load is predictable, and it's more predictable, it's not as if you have an unpredictable load pattern where it could scale massively and then drop massively, right? You don't have that kind of scaling pattern. You may still benefit from using a monolithic application architecture where your application is running on an EC2 instance because it's all predictable anyways, right? So look at things from the computing perspective and also from a release pipeline strategy perspective. The truth about it is, if you implement microservices architecture, it has certain benefits to it, but it also has certain downside. One of the downsides of a microservice architecture is complexity. Many people don't keep that in mind. If you implement the microservice architecture, it increases the amount of complexity that you have in terms of your application. The number of services that you have, all those individual services, you must manage those services, right? You must monitor those services. You must deploy those services individually. How many pipelines are you going to have if you have 100 services? Like, all of those stuff requires additional management and additional complexity. So consider all of this in terms of your architecture, your data management, your computing, your release pipeline strategy, before making that determination to say, I need to implement a microservice architecture, because you may find out that you actually benefit more from staying with a monolithic architecture. So some question in the chat window. Let me see. Ojo Williams says they all do have different use case, right? I'm guessing Ojo Williams that you're talking about the 17 services for running containers on AWS, and the answer to that is yes. They do have different use cases. So it depends on whether you're performing high performance compute tasks or whether you're performing, maybe you're running microservices, or whether you're running a multi-container solution that requires orchestration. So you have different use cases for the different services in terms of running containers. So that's absolutely correct. Okay, so let's quickly round up this one. So again, make sure you consider your architecture. So how do you decompose, or how do you break monolithic applications into microservices? If you have an existing monolithic application, you think you can benefit from moving to microservices, how do you do that? There are different patterns and different strategies that you can follow, right? So this particular one that I highlighted here, so this is from Sam Newman's Principles of Microservices. So Sam Newman had a presentation many years ago, actually. Let me see if I can bring it up. So it's the Principles of Microservices by Sam Newman. Let me bring that up. There you go. So I'll put it in the chat window also. So Principles of Microservices by Sam Newman. And that is where, like, a lot of, so this talk, that's where a lot of the information that you have on the screen, that's where they all come from. So I'll put this in the chat window to you. But let's quickly just go through like some of these key points in terms of what to consider when doing this. So number one, decentralize all the things. So instead of having one central system, distribute the functionality across multiple smaller services. Number two, we want to make sure that they can be deployed independently. So again, each microservices, you should be able to deploy it on its own. So that means you have separate release pipelines for each of them. and you should be able to deploy them without affecting the other services. Isolate failure. So we talked about this earlier. So an impact of a change on one service should not affect the functionality of another service. So you design your architecture that way. Highly observable. We talked about the complexity earlier. You have to monitor all the services. So comprehensive monitoring, comprehensive logging capabilities, make sure that's built into your services. And then some of the other thing, following the business model. So typically there's this thing about domain-driven design. So if you don't know about domain-driven design, so just Google Martin Fowler has a lot of content around domain-driven design. So, and the domain-driven design, DDD, and the whole point around domain-driven design is you want to organize your microservices based on different business functional areas. So the business has a need for users to be able to authenticate to the application. So you have a service for user authentication. Has a need for users to be able to search through the items in the database. So you have a service for search. So you essentially identify what your business objectives are, and then you have services for each of the key areas, right? But there's a lot more complexity to that. But again, Google Martin Fowler, domain-driven design, and you get a lot more information around that. So follow the business model. Implement automation. So it's beneficial if you automate the build, the test, and the deployment of your microservices using CI/CD. So we have Eseme will be here tomorrow talking about CI/CD. So make sure you attend that session to get more information about CI/CD. Hide implementation details. So the way that your services are exposed and they talk to each other, they should not have to understand the capability, the implementation detail of the other services. So they should all be abstracted from each other. So here is the homework that I have for you, and I'm going to put this in the chat window. So there is an homework that you can follow, which goes through breaking a monolithic application into a microservice on AWS. So I've done this tutorial myself, and I highly recommend you follow it. So Isaac already has his $25 credits. So you can use that for your practice, Isaac. So Isaac, so you can use that. So I put the link in the chat window. So it's a very nice tutorial by AWS. So what you're going to do, so again, I followed that myself, is you're going to go through a whole tutorial where you have a Node.js application, and you're going to break that down from a monolithic application. You're going to decouple them, and you're going to run them in different services on AWS, and you're going to implement that. So again, I highly recommend following this. And also you're going to containerize some of them, and then you're going to deploy the microservices. You're going to test it out. And here are the services that you're going to be using. You're going to be using EC2, ECS, Copilot, ECR, and Fargate. So again, highly recommended. So that's your homework. Make sure you follow that. So there's some questions in the chat window. Let me quickly address those before moving forward. So Jamilu said, does that mean microservices architecture will scale better than monolithic since they are decoupled? That is the idea, Jamilu. So the idea is they can scale better than monolithic. However, like many other things in technology, it's not always that straightforward, right? So for example, let me give you a very good example here. If you look at the link that I shared with you earlier on the AWS Prime Video team, one of the things that they talked about is to say the way that they were scaling actually created, when they moved to a microservice, when they used the microservices architecture, the way that the applications was functioning actually created scaling bottlenecks for them. So it all depends on how the application is designed and the way the application has been designed to handle scaling. So that also comes to it. But if you're just talking about from a generic standpoint, the idea behind that is you get better scalability out of monolithic applications, because again, you have smaller pieces of code that are deployed independently, and then you can scale each part independently depending on the load to that component, right, without affecting the other part. However, other things comes into play, like the way you've designed your application itself. So that comes into play. So So I can say Isaac answered that. Yeah, so that's the idea, but it's not always true. It depends. Like, again, this is a good eye opener in terms of, don't throw away monolithic application because of that. Keep that in mind. Microservices are not the only way to design modern application. You can design monolithic modern applications. Okay, so and I can see Okeyode that will be taking the session tomorrow on CI/CD. So again, make sure you join that session tomorrow. It's going to be interesting. So Okeyode says, how do you determine which architecture to use? So it depends on what you're trying to achieve. Similar to like the point that we mentioned earlier, if what you're trying to achieve will benefit from releasing different components much more quicker, right? If what you're trying to achieve will benefit from, let me bring up those characteristics again. Let's go very quickly to those characteristics. Right, will benefit now for these ones. Will benefit from using multiple languages, right? So multiple languages, multiple technology. You're going to be building an application, and the way that you've seen the application architecture, you think that you benefit from this component written in a completely different language and using a completely different technology stack versus this component versus every one of them using the same language and the same technology stack. You probably won't want to use a microservices architecture because monolithic architecture may not allow you to do something like that, right? So again, once you have a requirement for these characteristics that we have on the screen, then that's when you know that you need microservices versus a monolithic implementation, monolithic architecture. So let's see. So good question. Should all applications be microservices? No, they should not all be microservices. So monolithic is still very, very, useful. Again, I highly recommend reading the blog posts that I put for the other one. So let's conclude this. Developing microservices using AWS, there are multiple components and multiple services that are usually involved. Typically, we have combination of services that we use for compute. So in with services like EC2 for compute, Elastic Beanstalk, Lambda, again, depending on how you've implemented your microservices. Typically, microservices can communicate with each other using APIs. In that case, using the API gateway can help you to abstract a lot of the management, but they can also communicate with each other using queues or using just messaging mechanisms. So services like SNS and SQS also comes into that. So you have to determine whether you're going to be using queuing as your method of communicating between one microservice to another, or versus direct communication over APIs. There's advantages and disadvantages to each. So one of the advantages that you can get from leveraging something like queues is you can do something like load leveling, right? Which may not be possible using API gateway, using direct API communication. So load leveling is where you have service 1 that needs to communicate with service 2. If this is going over direct API communication, if service 2 is busy, then you begin to get, an error message back because it's overloaded, it's busy at the moment. Maybe it's still in the process of scaling up. So it's overloaded, it's busy. So you begin to get direct error messages back. But if you can decouple that, instead of direct API communication via API gateway, you put a queue in between them. And so service 1 can put whatever message that you want service 2 to process, put that in a queue. And service 2 can pick up the messages at its own pace. So that's where you're not getting like direct error messages and all this stuff. So there's advantages to leveraging direct API communication. There's advantages to leveraging queues and messaging mechanisms to get microservices to communicate with each other. Databases, microservices architecture, you probably see more of NoSQL databases and Amazon DynamoDB, serverless databases versus relational databases in that architecture. So you have those. So in summary, what did we talk about today? Talked about microservices, what they are. We talked about the characteristics to look for in a microservice architecture. We looked at understanding monolith versus microservices in terms of it's not always right to use microservices. Monolithic applications still provide a lot of value and they can be modern. And APIs being the front door of microservices. and leveraging services like either API gateway or message queues to abstract communication between the different microservices. Some other resources that I'm going to give to you. So here's a very good resource. So the resource itself is microservices.io. Let me bring this up here. Microservices.io. I'll put this in the chat window. So you want to review this. So it has a lot of very useful information on microservice architecture, but one of the ones that I wanted to bring up to you very quickly is this approach called the Strangler approach. So the Strangler approach is a popular approach if you want to migrate a monolithic application to a microservice application. And the whole idea behind that is you don't have to just migrate from monolithic to microservices like that. What you can begin to do is you can begin to move services from a monolithic application. So let's open this. So in this case, you can begin to move services from a monolith and begin to move them to microservices while you're still using the monolith, right? And then gradually, you're decoupling the services one after the other. You're decoupling the services one after the other till at the end of it, you have a very, very tiny monolith and there's nothing left in your monolithic application. And now you have tons of microservices. So this is called the Strangler approach. It's like you strangle the monolithic application. You just shrink it over time. You decouple it one service at a time. So you take maybe some of the least critical services and you decouple that over time, and then gradually you decouple the other one. Then gradually you decouple the other one. Of course, the monolithic application will have to be communicating to the services that you've decoupled over APIs, and then over time you have microservices with no monolithic application left. So again, I highly recommend going through microservices.io, going through something like the Strangler approach to understand, recommended approaches for migrating from legacy monolithic application to a microservice architecture. So ladies and gentlemen, that brings us to the end of today's session. If there's any question, I'll be happy to answer your questions. But if there are no questions, so that'll be it for me today. Tomorrow, we have another study series, another study session with Mr. Ukeme Eseme himself, and he's going to be talking about CI/CD. So I'm looking forward to that session. It's going to be great. So if there's any question, I'll be happy to answer. So Jamil said, today I clearly understood how SQS decouple microservices in your simple drawing, but can you please explain a bit of how SQS FIFO, first in, first out, works? I'm not going to attempt to go into into like that today. However, the whole approach is to give you a little bit of understanding, but I'm not going to cover everything like that today. I believe that there should be a session. I'll need to look up the session, Jamilu. I'll need to look at the sessions, but I believe that we should have a session where we talk about messaging. I believe that there should be one of those sessions on the timetable. So, but it's something that I'll need to go have a look at. So it depends on what you want to do. So you want the messages that's coming in the queue. So something like SQS FIFO will be useful if you have application that's doing business processing, right? Where it's important, the order of processing is important. Order of processing. So the order of processing, which means the first message that comes in needs to be processed first. So you take an example of that to be something like maybe an airline ticketing system, right? An airline ticketing system, you probably want the first person to click to say, I'm buying this ticket, to be the one that gets the ticket, right? So you want things to be processed in the order that they came in. So in that approach, in that scenario, you probably use something like SQS FIFO, right? So the first message needs to be processed first. But there are other use cases where you don't need, where you're not doing business processes and order of processing is not important, right? So maybe you're just sending a simple notification. Maybe it's just an event that you're sending. Maybe it's just a batch process. Then you don't need to use the first in, first out approach. So essentially the different the different consumers. So in case of this, you have your if your message produces, and then the message processors on this other side, they can pick up the message on the queue and just process them randomly or as they come in. So hopefully that gives you some more context, but we'll have some other sessions on messaging to go through that in much more details later. Okay, if there's no other question, so thanks very much for joining today. Isaac, make sure you send the email to us and we'll get your voucher over to you. Thanks very much for joining, everyone. See you tomorrow. Have a lovely rest of the day. Bye for now, everyone. So thanks for that, Sime. So thanks very much, everyone. See you next time. Bye.